My guest today is astronomer and astrophysicist Dr. Hugh Ross, and we're going to go right to his clip in his beautiful documentary movie Journey Toward Creation that shows you what scientists have discovered as they've gone back in time toward the moment when God brought everything into existence. I want you to watch this.
We'll need a new mode of transportation to carry us the rest of the way back to the moment of creation. Our new vehicles will be radio and far infrared telescopes. With these instruments, we can look back to the time before galaxies. If our eyes could see radio waves or infrared waves, we would be able to see distant galaxies more easily. But our eyes can only see electromagnetic emissions in the visible light wave spectrum. Waves in the radio part of the spectrum allow us to peer back in time even farther. This map of the cosmic background radiation, literally the radiation left over from the creation of the universe, carries our eyes as far back in time as any telescope can possibly take them. We cannot look back any farther because 380,000 years after the creation event, light first separated from darkness. The view before that time would only offer a featureless glow. We can't see beyond this glow because previous to 380,000 years after the creation event, the universe was too hot for atoms to exist. Electrons could not orbit around nuclei. Because the universe was nothing but charged particles, an amorphous glow is all that appears. For an earlier look, we need to use entirely different vehicles, entirely different instruments, particle accelerators, supercomputers, and gravity wave detectors, not telescopes. With these machines, we can duplicate many of the physical conditions of the cosmos at its earliest moments. The study of the cosmos can be compared with the backward running of a fireworks video. As we measure and observe the cosmos closer and closer to the first moment of its existence, we are running the tape backward toward the moment of creation. As we draw closer still to the creation event, we observe the universe becoming hotter and hotter. Eventually, in this backward replay, the universe will be so hot that protons and neutrons can't stick together. All atomic nuclei fall apart. Let's push on. As we probe even earlier, we encounter a blinding flash, just 1 millisecond from the creation event. This flash is generated by the sudden annihilation of all antimatter in the universe. A delicate balance of 1,000,000,001 particles to every billion antiparticles guarantees the existence of matter in the later universe, and it also guarantees the possibility of life. Pushing back to just a few dozen microseconds from the creation event, protons, neutrons, antiprotons, antineutrons decompose into even more fundamental particles called quarks. At 1/10,000,000th of a second from the creation event, the universe is too hot and too dense even for quarks to exist. At 100 billionth of a trillionth of a second from creation, the universe is too compressed for light to be possible. The universe is now completely dark and smaller than a single atom. All we see at this proximity to the creation event are the shrinking dimensions of length, width, height, and time. That is, until we reach a speck of time, just a 10 millionth of a trillionth of a trillionth of a trillionth of a second from creation. Before this moment, all 10 dimensions of the universe began to expand. After this instant, only 4 dimensions continue to expand. So what has happened to the other 6 spatial dimensions? they remain tightly curled up, smaller than a billionth of a trillionth of a trillionth of an inch, around our dimensions of length, width, height, and time. These other 6 dimensions still exist, but with no possibility of uncurling. Let's dare to roll back the film the rest of the way. The universe continues to shrink, the 10 dimensions growing smaller and smaller. At the creation threshold itself, often referred to as the Big Bang, all 10 dimensions become infinitely or near infinitely small and suddenly disappear. And it is from this infinitely small beginning that the entire universe sprang forth, and every aspect, from the formation of planets, galaxies, stars, to the relationship between the mass energy and the space energy density, and even the laws of physics themselves, must have been carefully fine-tuned from the creation event in order to make life possible for this brief moment in cosmic history on our tiny blue dot.
Hugh, for most of us as lay people, that's mind-blowing. But for the scientists, why does this start to the universe, which takes us back to Genesis 1:1? Why does it scientifically actually point to a creator, the God of the Bible?
We've been looking at the observations so far, but complementing that are theoretical work, where they can actually take the equations of general relativity and the fact that the universe contains mass and develop a theorem that actually proves that the universe has a beginning that includes a beginning of space and time itself, which implies that there must be a causal agent beyond space and time that created the entire universe. And it's that declaration that distinguishes what the Bible teaches about creation from what the other religions of the world teach. And so these astronomers recognize this is actually pointing to the God of the Bible. And over a period of 10 years, 2 astronomers, Arvind Borde and Alexander Vilenkin, spent 10 years trying to find a loophole. And the end was they produced another theorem, this one right here, which says that any universe that expands over its history must have this space-time beginning, and implies there must be a creator beyond space and time that created everything. And only a universe that expands is able to have life. So you're living proof that there must be a God beyond space and time that created the entire universe.
And does this God want us to know him?
Well, the very fact that he designed the universe in such a way that we could discover him through observing the universe tells us he wants to be known, he wants to have a relationship with us.